Hi friends, I'm here today again for another topic. We are going to statistics today. Under this, we want to look at measure of central tendency. What are the things we want to discuss under this measure of central tendency? So these are the things that we want to discuss. We want to look at meaning of measure of central tendency. We look at tools for measuring central tendency and the meaning of mean, median, and mode. Look at calculations of mean, median, and mode for ungrouped data and grouped data. Also, let's say in our analysis, we might also like to know when really do we use mean, median, and mode. Without wasting much of our time, let's start with the first one. So, meaning of measure of central tendency. In statistics, measure of central tendency is that single value that represents the entire population, or the single value that we use to locate the entire data set. Measure of central tendency is that single value that represents the entire data set. The single value that represents the entire data set. To understand what we are saying here, let's consider a family. In a family whereby you have father, this is the father. So we have mother, this is the mother. We have children. These are the children. These are the children. So let's say we are considering 4 children now. So the mother, the children, these are the children. So this is the mother. What do we notice here? This father will stand as the location for the entire family. That is, this will link to this. The children will also link to the father. This happens to be the single value in which each data or each set of data lies on. So the father could be the measure of central tendency for the entire population which is in the family. That is the meaning of measure of central tendency. Go. So let's look at the tools for measuring central tendency. What are the tools? When we say tools in statistics, so we have some statistical tools or measure that we can use in data analysis. So the one which we can use to measure the central tendency of any given set of data, or to get the location of any data set, are three. We have number 1, we have mean. 2, we have a median. 3, we have a mode. These statistical tools, these 3, are used to measure central tendency of any given data. So we can also have a distribution graph for these 3. When you have data like this, here, when it is normally distributed, that is the data given, here will be our mean, here will be our mean, here will also be our median, and this will also be our mode. We say it is symmetric. So the given set of data, that is the mean, median, and mode, they lie at the same point. So we say it is symmetric. So here, you may also have this. Here will be our mode, which is the highest one. Here will be our mean. And here will be our median. In this set of data, we discover that it's skewed to the left. Left skewed. The mean and the mode and the median, they are not in the same level. We can also have this. So here, this is our mode. This is our mean. And this will be our median. In this manner, we said the distribution is right skewed. Skewed. So these are the tools for measuring central tendency. Meaning of mean, median, and mode is the next thing we want to look at. So, what is the meaning of mean? The arithmetic mean of any given set of observations is obtained by summing up the entire population divided by the number of population. That is, the arithmetic mean of any given set of data is the summation of the entire population or observations divided by the total number of observation. It is also known as average. So here we may have the group data and non-group data. For the group data, for ungrouped data, given any set of values x1, x2, x3 till xn, the mean which is also written as x bar is given as the sum of x1 plus x2 plus x3 plus to the last value all over the number of observations. Of course, if you start counting 1, 2, 3 to the last number, we have n. So this can also be written as summation xi. I is a positive integer from 1 to n all over n, which is the same thing as 1 over n summation x. So this is used to calculate the mean of any given set of data if it is not a group data. So we can easily say, based on the definition, that mean is equal to sum of entire observation divided by number of observations. Sum of entire observation all over number of observations. So the sum is this summation x. The number of observations is n. But for group data, if it is group data, for grouped data, here frequency will be involved. If we are given any group data, there will be frequency. So when there is frequency, the formula for calculating the mean will actually change. As e.g., let's say you are given set of data x1, x2, x3 till xn with respective frequency f1, f2, f3 till fn. Then the mean, which is x bar, is given as f1 times x1 plus f2 times x2 plus f3 times x3 plus to the last value fn times xn all over. The frequency will now be the number of observations. So we are going to have f1 plus f2 plus f3 plus fn. Of course, we can also write this as summation fi Your I is from 1 to n, then xi all over summation fi I from 1 to n. So this is the formula to calculate the mean of any given set of data if it's grouped data. But for ungrouped data, we are using this to calculate ungrouped data. That is when there is no frequency. Let's look at the next one now. Median is the next thing we want to consider. Under this mean, median, and mode, we want to look at median now. So what is median? When you are given any set of data, then the value at the middle, after arranging in ascending order or descending order, is our median, or that value that divides the higher part of the distribution against the lower part of the distribution is also known as the median. That is, median is a value that is at the middle after arranging sets of data in ascending order or descending order. That is our median. For example, let's say you have this set of data. Let's say you have x1, x2, x3. Provided that this arrangement is in ascending order, so we discover that this x2 is the value at the middle. So this is our median. Or in a distribution, if we move back to our graph, so here is our median. So it divides this right and this is left. So this median divides the right and the left of the distribution, or the higher part and the lower part. Like if you have so this is the higher part. If you have this, if this is your mean, so here is the median. Of course, this is our mode. So we discover that from here, this is the higher part, and this is the lower part. So this median divides the higher part from the lower part. This is what we mean by median. So median can also be calculated when the data given is grouped. So here, when the data is ungrouped, we can use this method by arranging like ascending and descending order. We easily pick the value. So like S1, this is the value. And there are some conditions whereby the middle value will be even. So when your data is evenly distributed, for example, let's say the data is evenly distributed. You have x1, x2, x3, and x4 here. So when you want to pick the middle value, we discover that these two will be the middle value. So in this manner, what do? We just sum up this. We sum up this even number, which is the middle value. There are two. You now have your median equal to x1 plus x2 plus x3 divided by 2. That is, we find the arithmetic mean of the two numbers at the middle. But here, when you have only single value, that single value at the middle is our median. When we have two, we find the mean. That is how to get our median when the data set is not good. But let's say we are dealing with a group data. What is the median? The median is given by this formula. So we have this formula for calculating the mean when the data is grouped. For grouped data, so we have median equal to Li plus summation f over 2 minus CFB all over f times C. So this is the formula for calculating the median of any group data. So where Li is equal to lower class boundary of the median class, then summation f over 2 is the median position. So we use this to find the median position. Then CFB is equal to cumulative frequency before the median class. F here is equal to frequency of the median class, and C is equal to class size. So this is the formula to calculate the median of group data. So let's quickly look at the last one. The next one is mode. So mode can be defined as the value that occurs most frequently in a given set of data, or mode is the value that has the highest frequency in a given set of data. Mode is defined as the value or number with the highest frequency. It is also the number that appears most frequently in a given set of data. So what are we saying? For example, let's say you have a 2, or you have x1, x2, x3, x1, x3, x1. So the number that appears most here, if you count it, x1 appears 1, 2, 3, 3 times. 3 appears twice. So we say that our mode is S1. Mode is equal to x1. That is, it appears most. So it's the number that appears most, which is x1. That is our mode. And if you are given a group distribution with frequency, like let's say you have x, you have f, this is 3, 1, 4, 5, 2. You now have 5, 6, 7, 8, 9. Here, the number with the highest frequency is the mode, which is 5. 5 is the highest frequency. So 8 is the mode. 8 appears 5 times. 5 appears 3 times. 6 appears once. 7 appears 4 times. So the one that appears most frequently is 8. Or the one with the highest frequency is 8. That is the definition of mode. Now, let's look at different forms of mode. Forms of mode. These modes can be in different forms. For example, we have a unimodal, we have bimodal, we have trimodal, we also have a multimodal. So under the bimodal, e.g., when you have a single value that appears most, we call it bimodal. When you have let's say you have 2, 3, 4, 6. So our mode here, 2 appear most. So mode is equal to 2. So in this manner, when you have a single mode or single value that brings us the mode or the modal mark, we say it is unimodal. But when you have two numbers having the same mode, like 2, 4, 5, 5, 6, 6, 7, 8. So here 5 and 6 are the mode. 5 appears 2 times, 6 appears 2 times, while others appears once. Therefore, the mode is equal to 5 and 6. Here we say it is bimodal. But trimodal, that is when you have 3. And multimodal, when you have many. That is more than 3 mode. 3 numbers, let's say 4 numbers appears to be the mode, or to occur most frequently. We now say they are multimodal. These are forms of mode. Now, let's look at mode of grouped data. For group data, the mode is given by this formula equal to M naught equal to Li plus change 1 all over change 2, or change 1 plus change 2 times C, where your Li is equal to the lower class boundary of the modal class. Lower class boundary of the modal class. Then change 1 is equal to the difference between the frequency of the modal class and the frequency above the modal class. Difference between the frequency of the modal class and the frequency above the modal class. So, if the frequency between the modal class is written as Fm, that is frequency of the modal class, then the difference minus frequency above Fa. So let's denote it as Fm minus Fa, frequency of the modal class and frequency above the modal class. That will be our change 1. Then change 2 is equal to frequency or difference between the frequency of the modal class and the frequency below the modal, the frequency below the modal class. So, if the frequency below the modal class is denoted as, if we denote it as FB, and the frequency of the modal class is denoted as FM. Then we can now have change into equal to FM minus FB. Frequency of the modal class minus frequency below the modal class. So our C, which is from the formula, our C is the class size. C is equal to class size or class width. We can now reform our formula. If we substitute this and this, then this formula can be written as mode is equal to Li plus, instead of writing this, we are putting this Fm minus Fa, Fm minus Fa all over. So instead of writing this, we are going to have Fm minus Fa, then plus change it to, which is Fm minus Fb, Fm minus Fb times C. So our M naught is equal to Li plus Fm minus Fa all over this plus this will give you 2 Fm then minus Fa minus Fb times C. So this is the formula for calculating the mode of grouped data. How can we use these tools to calculate data? That is the next thing we want to look at now. Calculations of mean, median, and mode for ungrouped data. Like we said, we can calculate the mean, mode, and median for ungrouped data. Let's look at example. Example 1. Calculate the mean, median, mode of the data set below. Under the question number 1 and question number 2, Roman figure 2. So let's write our solution. So number 1, A, under the Roman figure 1, we have to calculate mean. By the given formula, we know that mean, which is x bar, is equal to, so how many observations do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to have x1 plus x2 plus x3 plus 2x9 all over the number of observations is 9. So this is our S1, this is our X2, X3, X4, X9. So let's substitute. We are going to have 2 plus 5 plus 3 plus 2 plus 6 plus 4 plus 2 plus 3 plus 4 all over 9. So we are going to add, we can use our calculator. With our calculator, we can add everything. So this is 7, 7 plus 3 is 10, 12, 18, 22, 24, 27, and 31. So it's going to be 31 all over 9. Or we can put it in decimal fraction, which is 31 divided by 9, which is 3.44444. 3.444 like that. So we can approximate it to 3.4. So this is our median for the first question. So let's look at the median for the second question. A, Roman figure 2. So this will be our x1, x2, xcd, x4, x5, and x6. So the formula will move from 1 to 6 instead of 9. Our mean now, which is x bar, will be x1 plus x2 plus xcd plus x4 plus x5 plus x6 all over the number of observations, 6. So let's substitute. We have 4. 4 is our x1 plus 5 plus 2 plus 2.1 plus 3.2 plus 4.5 all divided by 6. So now we can add with our calculator. So we have 4, 4 plus 5, 9, 9 plus 2, 11, 11 plus 2.1 plus 3.2 plus 4.5. So it's going to be 20.8. 20.8. 20.8 all over 6. So when we divide it, so divided by 6, we are going to have a 3.4667. So we can approximate it to 3.5. So this is our median. So now let's look at how we can calculate the median. That's our mean. Sorry. How we can calculate the median. A or B, Roman figure 1, the median. So we're calculating the median. Under this, so let's rearrange. Arrange the data in ascending order. So let's rearrange in ascending order. So for Roman figure 1, we're having 2, followed by 2, 2, then 3, 3, then we have 4, 4, we have 5, and we have 6. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now, we want to find the middle value. So if you are counting 1, 2, 3, 4, 1, 2, 3, 4. So from here, so the number, this is a single number at the middle. Therefore, median is equal to 3. So let's look at the second one. B, Roman figure 2. Under this set of data, we are going to rearrange as well. Rearrange in ascending order. So the first one is 2, followed by 2.1, followed by 3.2, followed by 4, followed by 4.5, followed by 5. So we have 1, 2, 3, 4, 5, 6. So here, we want to look at the middle value. If we are counting here, here. So these are the values at the middle. So this is even number. We find the arithmetic mean. Let's find the arithmetic mean of these two values. So our median will be equal to 3.2 plus 4 divided by 2, which is equal to 3.2 plus 4 will give us 7.2 all over 2. So we can divide it. We're going to have 3.6. So this is the median for the second data here. So we are done with A and B. Let's look at the mode. So how do we calculate the mode? So mode is the number that appears most frequently. So if you look at this A, the number that appears most is 2. So let's go back to the arrangement of that median. So we have 2, 2, 2, which is 3 times, 3, 3, 2 times, 4, 4 is 2 times, 5 and 6, 1. So our mode, the number that appears most here is 2. So we have a C Roman figure 1. Mode is equal to 2. That is 2 appears most frequently. So 2 appears most frequently. So what about this? We have 4, 5, 2, 2.1, 3.2, 4.5. So there is no any number that appears most here. In this situation, we don't have mode. We write no mode. C, Roman figure 2, no mode. All the numbers appears at the same time. So there's no anyone that appear most. In that manner we said no mode. So that is the end of this calculation for ungrouped data. How do we calculate group data?